Hey Patriots, welcome back from your break. It's time for us to get started on our next unit. And the first thing you're going to need is this piece here, the ratios and proportions notes. I passed these out to everybody in class. If you either weren't here or lost yours for any reason, feel free to print it off. It's all in Google Classroom. We're going to go ahead and take this thing and fold it in half this direction. Now the thing you want to make sure if you're printing your own at home is that you're going to print it two-sided, and you're going to flip it along the short edge, because if you flip it along the long edge, it's going to put this side upside down. So let's go ahead and jump into this. Our entire Unit 7 is going to be over ratios, proportions, and similar figures. The whole point of this unit is to start understanding how two figures that are the same shape but different sizes, how all those different side pieces and angles and everything interact with each other. But before we can do that, we've got to get the tools down in order to solve those problems. So that's where we're starting off with ratios and proportions. So let's go ahead and jump into this. Our ratios and proportions. All right, first off, ratios. What is a ratio? It is a relationship between two quantities. A relationship between two quantities. Now, all that means is we're talking about two number quantities that typically are related in some way. Like, for example, miles per hour is a ratio, because we're talking about relating the number of miles you've driven to the time it takes you to get there. Okay. Also, if you did something weird like the number of pieces of sand on a beach, again, you're relating numbers of sand to the number of beaches, which in this case is 1. Okay. There are 3 different ways to write to write a ratio in different forms: words, the ratio format, and fractions. Now, the example we're using here is a store that sells 5 apples in each bag of apples. Now, words can be written different ways. You could be using the word per, you could be using the in each, that sort of thing. There's literally numerous ways that can be written. There's no way I can cover them all. A ratio, though, is going to be written with a colon, sort of like you saw back in probably late elementary, early middle school. We're going to make sure that we clearly define which quantity value is on each side of this colon. So in this case, I'm going to put apples on the left and bags on the right. So whenever I write my actual number, it is 5 to 1. Now, in our reality, it does not matter one bit whether I put apples on the left and bags on the right, or switch them and put bags to apples. As long as these numbers match the appropriate idea, that's fine. Because if I'd written 1 to 5 with apples to bags, that doesn't really work out. One apple to every 5 bags doesn't exactly work out. But you could write them either way, and I'll point out why that's actually or you could write it in any order. Why the order doesn't matter when we get down here to example number 6, and I'll show you that down there. Okay, now the fractional form. We're still going to be defining where we're putting things, and in this case, we're going to just, instead of writing it with a colon, write it with a fraction bar. So apples over bags. So in this case, it would be 5 apples over 1 bag. Okay. Now, if I'm trying to relate these two, a ratio form to a fraction form, make sure that the left side goes in the numerator and the right side goes in the denominator. Now, since we are doing this on an Edpuzzle and not on a straight YouTube, I have the ability to ask you guys questions and then give you grades based on how you answer those questions. So let's start off with the first one. I'm going to ask you a question, and then it'll pause, and it will tell me at the end what your grade was. Hey, I like that. Easy grades for you guys and easy grades for me. I'm going to try and make these easy, really just to make sure that you guys are paying attention and you're not just clicking through things. So first one is, looking at this page, how many ways are there of writing ratios? All right, I really hope you got 3 there. Just 1, 2, 3. Please take the easy questions when you get them. Okay. example number 1. In 2007, the Boston Red Sox baseball team won 96 out of, and this is 12, it should have been 126. 96 out of 126 games played. Write the ratio for the number of games won to total games played. Now, I could write this two ways, and when I just say write a ratio, I don't care whether you use this form or this form. It doesn't matter one bit. In all reality, though, this one, the fraction, is the most useful mathematically, and so that's what I want you to get used to seeing. But for the purpose of example here, I'm going to write it in both formats. So, writing it in ratio form is going to be the games won to the total games played. Well, my games won is 96, to games played is 126. If I was doing it as a fraction, it would be games won divided by games played. Notice here I'm not writing the entire word out. I'm using this more as a variable style. Again, it doesn't matter. The whole idea is as long as I can tell which number is on top and which one's on bottom, that's what's important. Okay? Now, won is 96, played is 126, and again, I would accept either one of those as the correct answer. All right, example number 2. There are 87 people in the high school band. Each person plays either a brass instrument, woodwind instrument, or percussion. And there are 34. If there are 34 brass players in the band and 42 woodwind players in the band, write a ratio for the number of percussionists to total band members. So it looks like my ratio will be written as percussionist to total. Percussionist to total. Well, as I'm going through here, it looks like there's 87 people total, but I don't have the number of percussionists anywhere. That's why it's important that everybody has to fit into one of these 3 categories. Since I know brass and woodwind, I can just subtract those out from 87 and be able to get it. So 87 minus 34 minus 42, and that is going to give me 11 people left over. Don't feel bad that I did that in my head if you can't, because I literally have a cheat sheet over here. So don't feel bad. 11 to 87. If I was to write that as a fraction, it would be percussionist divided by total, which again is just 11 divided by 87. Either one of those works. Okay? Now, moving on to page number 2. A proportion. A proportion is always going to be written as fraction equals fraction. Now, this is important because so many times I get students who forget to put that equal mark, and that equal mark is extremely important. Now, what it actually is a proportion is used to find the relationship between 2 related ratios. Now, this is what a proportion is going to look like. Again, fraction equals fraction, fraction equals fraction. Now, in order to solve this, we're going to be using one of those tools that you learned, again, back in late elementary, early middle school, whenever that came up, which is cross multiply and divide. Just to be completely honest, I hate this phrase. I wish that it had been taught to you right the first time around. Cross multiply and divide is great in certain circumstances, but there's other times it's going to leave you high and dry. I'll show you when that happens here in just a minute, and I'll come back and I'll change this to what it actually should be. But just to let you know, again, I do not like this. I don't ever want to hear you say cross multiply and divide in my class. You're going to use the one that I teach you here in a second. All right, so let's go and do this. Cross multiply is 3 times 14. And 3 times 14 comes out to 42. And then 4 times x is 4x. Now, in order to get x by itself, we're going to have to divide by 4. And so 42 divided by 4 is 10.5. Now, in this particular case, it actually was cross multiplying and dividing. But realize the reason you had to divide here was because this step needed you to, because it was 4 times x, so divide by 4 to get rid of this coefficient here. However, let's look at it in example number 4. 2 times 45 is 90. 1 times y plus 9. Now be careful here, because what's actually going on is when we multiply a monomial times a binomial, we have to distribute this term across the other two. Now it's a 1, so it doesn't really matter, but in other cases it actually will be a bigger number there. So I'm doing this entire process just to show you what's actually going on there. So 1 times y is y. 1 times 9 is 9, and I've got a 90 here on the left. And now I've got to get rid of this 9, and the way I do that is not by dividing, but by subtracting. So 90 minus 9 is 81. And this right here is why I hate the phrase cross multiply and divide. Because if you try and cross multiply and divide every single time, then on problems like this, you're going to divide by 9 and get 10, which is completely the wrong answer. See, this divide word shouldn't be there at all. It should actually be the word solve. Cross multiply and then do whatever is necessary to solve for the variable. So don't say cross multiply and divide. You'll hear me say over and over again cross multiply and solve. All right, let's go on to number 5. So Raul is playing a board game. After 14 turns, he landed on green spaces 4 times, and if the game will last for 84 turns, predict the number of times that Raul will land on a green space. I love this word predict here, because that's what proportions can be used for in many cases, is to do predictions. Let what's happened in the past help you predict what's going to happen in the future. Not always scientifically or statistically accurate, but it does give us a good baseline for things. So it looks like what we're relating here is the number of times that he hits a green space, and we've also got the number of turns that have elapsed. So I'm going to do green spaces divided by turns. And you'll notice me writing this every single time. Just like I did on this previous page, I wrote it here, there, and then also here. I always want to know what my variables are at any given time. So when I first, let's look at what's happened in the past, okay? What's already happened up to this point. He's had 14 turns, which turns is going to be on bottom, so 14 goes here. And then green spaces are 4, so green's go on top, that gives me 4. That equals my second fraction, which is what I'm going to use to predict. At the end of the game, we're predicting 84 turns. Again, turn is on bottom. And I don't know how many green spaces, so I'm going to put a variable there. Now I can cross multiply and solve. 4 times 84, do it in the calculator if you need to, but 4 times 84 is 336. 14 times x is 14x. Then our solve step, in this case we do need to divide. Divide by 14 gives me x equals 24. So I'm predicting that I'll hit green spaces 24 times in an 84 turn game. All right, example 6. Famous painting is 84 inches long and 23 inches wide. Small replicas of the painting are being sold in the museum gift shop for 8 inches wide. How long are the replicas? I'm going to go ahead and draw this. I'm going to do my length and my width this way. 45 long and 23 wide. And I've got my smaller versions in the gift shop, which are going to be, well, if I did length and width here, length is still got to be on the top and width is still got to be on the side. So it's 8 inches wide. I want to know my length, which I'm going to use y as my variable. Okay, so I am going to set this up. Looks like my two number quantities here are length and width. So I'm going to put just length on top, width on bottom. And that is going to mean that for my first painting, length is 45, width is 23, equals my second painting, length is y and width is 8. Sorry, go behind my head there for a second. All right, let's cross multiply. 23 times y is 23y. 8 times 45 is 360. Now, let's go ahead and cross multiply these. I'm sorry, not cross multiply. We already did that. Let's divide 23 divided by y. I'm sorry. Divide by 23. Give me 1 second. Divide both sides by 23, and 360 divided by 23 is going to come out to 15.65. All right. So I promise you guys that we would, at this point, go by and show you why it does not matter whether we had put 5 over 1 over 5, apples to bags or bags to apples. Okay. And this is what happens here. Let's just say that we're going to, instead of doing length over width, we're going to do width over length. Okay? Now, what I want to do is reset this entire thing as fraction equals fraction. Okay? So, width over length would mean that my first one, the width is 23, and my length is 45. And now for your second question of the ed puzzle is, where is the y going to go? Okay, this y here, is it going to go on top or on bottom? All right, so let's try this. Hope you all got that right. Again, another pretty easy one. The length, or sorry, y is for the length, and length is on bottom, so that y is going to go on bottom. Here, we're going to put our 8 on top for the width. And you notice when I cross multiply, 23 times y still gives me 23y, just like I had before. 45 times 8 still equals 360. And again, I have the exact same equation here and here. That's why the order doesn't matter, as long as you're consistent on both of them. If both your lengths are on top or both your lengths are on bottom, it doesn't matter, as long as they're both consistent. All right, moving on to page number 3, extended ratios. I'm going to be completely honest with you guys. I don't think this is really that big of a topic. Honestly, the only place I've ever seen this is in a geometry class. I've never used it anywhere beyond this, but it's mandatory in the curriculum, so we're going to go ahead and go over it. I'm going to simplify this as simply as possible. Extended ratios look like this, where I've got more than 2 in there. It's going to be used to show the relationship between 3 or more related ratios. Okay, so instead of it just being 2, we could have 3, 4, 5. Hey, you could go out to 1,000 if you wanted it to. I would never do that to you though. All right, so now 2, 5, 8, and 9. What we're actually going to do here, we can't use proportions because proportions are used for only 2 related ratios. What we're going to have to rely on is there also being some sort of total value. Okay? And what we're going to do is set this up, put a variable behind every single one of these. So 2x, 5x, 8x, and 9x. All I did was put an x behind each of those and take out the colons. Now, if I also have a total, then I could just add all of these together and make it equal that total value. So then I have an equation that I can solve. Combine like terms on the left and then divide through to find what the total, or to find what the value of each x is. Okay? Let's actually see that in action here. The ratio of the lengths of sides of a trapezoid are 3, 4, 7, and 5. Okay, so here's what's actually going on. And by the way, I did not test to see if this would actually make a trapezoid whenever I made this. This is 3, 4, I'm sorry, not 5, 7, and 5. But it says the ratio is that, not that they're exactly 3, 4, 7, and 5. So what I'm going to do is put an x on each of these. It also tells me that my perimeter equals 76. So if I add all of these together, I'll add all the sides of the trapezoid together, that just gives me perimeter. So all of these together, sum of these equals 76. 3x plus 4x plus 7x plus 5x equals 76. There's my equation. Let's combine like terms on the left. So 3 plus 4 makes 7. 7 plus 7 is 14. 14 plus 5 is 19. So 19x equals 76. Now, let's divide by 19. That gives me x equals 4. Now, the next question I'm going to ask you, question number 3 on this, am I done right now? I really hope you said no. I really hope you're paying attention to saying what are the lengths of all the sides of the trapezoids, not the value of x. So in order to find that, I'm going to have to come, scoot over so I don't get behind my face there. 3x, 4x, 7x, and 5x. Well, 3 times 4, 4 times 4, 7 times 4, and 5 times 4. We're just going to plug in 4 for the x value on all of these. That gives me 12, 16, 28, and 20. So the sides of that trapezoid are 12, 16, 28, and 20, which if you add all those up, sure enough the total gives you perimeter is 76. All right, number 8. The ratio of the measures of the angles of a triangle are 7 to 11 to 12, and its perimeter is 76. What are the measures of the angles of the triangle? To be quite honestly with you, I forgot to delete this perimeter of 76 whenever I copied and pasted from this problem. But we'll use it because it's good to get used to seeing extra information in problems. This perimeter is not going to affect us at all. Let me go ahead and draw a triangle here. Here we've got 7, 11, and 12 in the angles, and remember I'm putting x's there. Again, our perimeter is 76, and once again it's not going to affect us because there is no direct relationship between angle measures and side lengths. So let's see, our perimeter here is 76. I'm sorry, that didn't matter one bit, I got distracted. All right, so 7x plus 11x plus 12x is going to equal something that we need for a total value, but there's no total value given to us. Well, we can go back to our information we learned from last semester to know that the angles inside of a triangle always add up to 180 degrees. All right, so 7 plus 11 is 18, plus 12 gives me 30x equals 180. Divide both sides by 30, gives me x equals, not 60, x equals 6. All right, actually, you know what? I took the bait. I'm not done yet, okay? X equals 6 means that I've got to go in and find the measures of the angles of the triangle. So 7x, 11x, and 12x. 7 times 6, 11 times 6, and 12 times 6. And I forgot to write these down on my cheat sheet, so I'm going to have to maybe use my calculator here in a second. 7 times 6 is 42, 11 times 6 is 66, and actually I don't. 12 times 6 is 72. So the measures of my triangle are 42, 66, and 72. All right, so last question right here at the end, just to make sure you guys have listened all the way through. What is the page number that I am finishing on? Hint, hint, it's right there. Okay, now for what you're going to do with this side has a X on it. What you're going to do is glue on here. We're going to take out our notebook, and yes, I realize we kind of got behind on filling out our notebook. I'm also going to start standardizing the pages that we're on. So whatever is your next page available, here mine was there. I am just going to start labeling this as page 100, and you'll notice that on your playlist it says to glue this in on page 100. So go ahead and take your glue that side, plop it in here on page 100, and we'll all be on the same pages from now on. So you've got that there. All right. Thank you guys, and good luck with the assignments.